Welcome to
Andalas University!
Universitas Andalas is a state university established on September 13, 1956. The main campus is located in Padang, the second in Payakumbuh, and the third in Dharmasraya. Since August 31, 2021, Universitas Andalas becoming the legal entity state university. The vision of Universitas Andalas is to be an outstanding and dignified university with 4 missions and a long-term strategy for 20 years. Universitas Andalas is accredited superior by the National Accreditation Board and has been in the first cluster along with 15 universities based on academic staff research performances. 15 study programs have been internationally accredited or certified by ABET, IABEE, FIBAA, ABST 21, and AUNQA. The university supports study programs to meet international quality standards. Study programs that meet the requirements are facilitated to be assessed by the international accreditation boards, such as the Royal Society of Chemistry, the Foundation for International Business Administration Accreditation, and by the Accreditation Agency for Study Programs in Engineering, Informatics, Natural Sciences, and Mathematics. Universitas Andalas has made policies to ensure high-quality education, including the academic guidance, the ethical conducts, the guidance for students' internship, student exchange, and students' mobility programs. The university also have had a rector's degree on internal quality assurance system, the internal quality standards, and the Manual of Internal Quality Assurance System. The total number of students is more than 30,000 who come from various provinces in Indonesia and other countries. They were spread over 137 study programs at the vocational, undergraduate, professional, master, or doctor levels. Many scholarships have been offered to the students. The teaching and learning process is held in common classroom with various capacity. The internet bandwidth is 165 Mbps, which can be accessed using LAN and Wi-Fi. Supporting facilities for students include dormitories, health clinic, university hospital, mosque, bank center, student center, career and development center, cafeterias, and various sport facilities. There are 1,462 academic staff consisted of 161 professors, 380 associate professors, and 506 assistant professors. The academic staff also conduct researches and produce publication in reputable journals. The academic staff to student ratio is 1/19, and the supporting staff to student ratio is 1/17. To ensure the sustainability of the campus in the future, Universitas Andalas has had an integrated waste management system, an integrated water management system, a micro hydropower plant inside the campus.
For the glory. Glory ya, no ya. Oh, pakai media player, Cok.
Welcome to
Mas Bro.
Universitas Andalas is a state university established on September 13, 1956. The main campus is located in Padang, the second in Payakumbuh, and the third in Dharmasraya. Since August 31st, 2021, Universitas Andalas becoming the legal entity state university. The vision of Universitas Andalas is to be an outstanding and dignified university with 4 missions and a long-term strategy for 20 years. Universitas Andalas is accredited superior by the National Accreditation Board and has been in the first cluster along with 15 universities based on academic staff research performances. 15 study programs have been internationally accredited or certified by ABET, IABEE, FIBAA, ABST 21, and AUNQA. The university supports study programs to meet international quality standards. Study programs that meet the requirements are facilitated to be assessed by the international accreditation boards, such as the Royal Society of Chemistry, the Foundation for International Business Administration Accreditation, and by the Accreditation Agency for Study Programs in Engineering, Informatics, Natural Sciences, and Mathematics. Universitas Andalas has made policies to ensure high-quality education, including the academic guidance, the ethical conducts, the guidance for students' internship, student exchange, and students' mobility programs. The university also have had a rector's degree on internal quality assurance system, the internal quality standards, and the manual of internal quality assurance system. The total number of students is more than 30,000 who come from various provinces in Indonesia and other countries. They were spread over 137 study programs at the vocational, undergraduate, professional, master or doctor levels. Many scholarships have been offered to the students. The teaching and learning process is held in common classroom, with various capacity. The internet bandwidth is 165 Mbps, which can be accessed using LAN and Wi-Fi. Supporting facilities for students include dormitories, health clinic, university hospital, mosque, band center, student center, career and development center, cafeterias, and various sport facilities. There are 1,462 academic staff consisted of 161 professors, 380 associate professors, and 506 assistant professors. The academic staff also conduct researches and produce publication in reputable journals. The academic staff to student ratio is 1/19, and the supporting staff to student ratio is 1/17. To ensure the sustainability of the campus in the future, Universitas Andalas has had an integrated waste management system, an integrated water management system, and a micro hydropower plant inside the campus.
Berapa peserta yang matikan mic-nya?
Welcome to
Universitas Andalas is a state university established on September 13, 1956. The main campus is located in Padang, the second in Payakumbuh, and the third in Dharmasraya. Since August 31st, 2021, Universitas Andalas becoming the legal entity state university. The vision of Universitas Andalas is to be an outstanding and dignified university with 4 missions and a long-term strategy for 20 years. Universitas Andalas is accredited superior by the National Accreditation Board and has been in the first cluster along with 15 universities based on academic staff research performances. 15 study programs have been internationally accredited or certified by ABET, IABEE, FIBAA, ABST 21, and AUNQA. The university supports study programs to meet international quality standards. Study programs that meet the requirements are facilitated to be assessed by the international accreditation boards, such as the Royal Society of Chemistry, the Foundation for International Business Administration Accreditation, and by the Accreditation Agency for Study Programs in Engineering, Informatics, Natural Sciences, and Mathematics. Universitas Andalas has made policies to ensure high-quality education, including the academic guidance, the ethical conduct, the guidance for students' internship, student exchange, and students' mobility programs. The university also have had a rector's degree on internal quality assurance system, the internal quality standards, and the manual of internal quality assurance system. The total number of students is more than 30,000 who come from various provinces in Indonesia and other countries. They were spread over 137 study programs at the vocational, undergraduate, professional, master or doctor levels. Many scholarships have been offered to the students. The teaching and learning process is held in common classroom with various capacity. The internet bandwidth is 165 Mbps, which can be accessed using LAN and Wi-Fi. Supporting facilities for students include dormitories, health clinic, university hospital, mosque, band center, student center, career and development center, cafeterias, and various sport facilities. There are 1,462 academic staff consisted of 161 professors, 380 associate professors, and 506 assistant professors. The academic staff also conduct researches and produce publication in reputable journals. The academic staff to student ratio is 1/19, and the supporting staff to student ratio is 1/17. To ensure the sustainability of the campus in the future, Universitas Andalas has had an integrated waste management system, an integrated water management system, and a micro hydropower plant inside the campus.
Welcome to
Universitas Andalas is a state university established on September 13, 1956. The main campus is located in Padang, the second in Payakumbuh, and the third in Dharmasraya. Since August 31, 2021, Universitas Andalas becoming the legal entity state university. The vision of Universitas Andalas is to be an outstanding and dignified university with 4 missions and a long-term strategy for 20 years. Universitas Andalas is accredited superior by the National Accreditation Board and has been in the first cluster along with 15 universities based on academic staff research performances. 15 study programs have been internationally accredited or certified by ABET, IABEE, FIBAA, ABST 21, and AUNQA. The university supports study programs to meet international quality standards. Study programs that meet the requirements are facilitated to be assessed by the international accreditation boards, such as the Royal Society of Chemistry, the Foundation for International Business Administration Accreditation, and by the Accreditation Agency for Study Programs in Engineering, Informatics, Natural Sciences, and Mathematics. Universitas Andalas has made policies to ensure high-quality education, including the academic guidance, the ethical conduct, the guidance for students' internship, student exchange, and programs. The university also have had a rector's degree on internal quality assurance system, the internal quality standards, and the Manual of Internal Quality Assurance System. The total number of students is more than 30,000 who come from various provinces in Indonesia and other countries. They were spread over 137 study programs at the vocational, undergraduate, professional, master, or doctor levels. Many scholarships have been offered to the students. The teaching and learning process is held in common classroom with various capacity. The internet bandwidth is 165 Mbps, which can be accessed using LAN and Wi-Fi. Supporting facilities for students include dormitories, health clinic, university hospital, mosque, bank center, student center, career and development center, cafeterias, and various sport facilities. There are 1,462 academic staff consisted of 161 professors, 380 associate professors, and 506 assistant professors. The academic staff also conduct researches and produce publication in reputable journals. The academic staff to student ratio is 1/19, and the supporting staff to student ratio is 1/17. To ensure the sustainability of the campus in the future, Universitas Andalas has had an integrated waste management system, an integrated water management system, and a micro hydropower plant inside the campus.
Assalamualaikum. Halo Dr. Muazu. Hello,
Amin
Dr.
walaikum
Muazu. Can you hear me?
salam.
How are you?
I'm doing fine, and you?
Yeah, I'm fine also. Thank you. How was going on? Yeah, okay. We can see your face very well now.
Yeah.
Yeah. We heard that you just finished Umrah, I think. I'm correct?
Yes, I just back yesterday.
Oh, yesterday. Oh, thank you so
Yes.
much for prepare today's seminar.
Yeah.
Everything fine during the
Alhamdulillah.
trip? Alhamdulillah.
Alhamdulillah. Yes.
Okay, you go with your parents?
Yes, yes,
Family?
yes.
Okay.
Yes.
Nice.
Mm.
Nice.
Yeah.
Yeah. Actually, in Indonesia, in West Sumatra, now is 2 p.m.
Okay.
Yes. How about in your country? Morning?
My country, this is 8 a.m.
8 a.m. Oh, nice. Nice time to
Yes.
start.
Yeah. Mm.
Yeah. Okay. Yeah, already joined in this Zoom meeting. Let me check. Yeah, Dr. Rian. Yeah. Also already joined Mr. Ahmad Safruddin, our dean,
Okay.
and other lecturer from Department of Computer Engineering and Department of Information Science and Informatics.
Okay.
Assalamualaikum.
Good morning, Prof. Musa.
Yeah. Good morning, sir.
How are you?
I'm doing fine, Prof.
Okay, so do I. So, thank you for your presentation, two presentation. Okay.
Thank you, sir.
Sip lah, Pak Budi.
Yes.
Mulai aja, Pak Budi.
Okay, Pak. Yes. Okay, Dr. Musa, I think we are already here, and yeah, please let me share the slide first. I think your slide.
No, I can share my screen if you can allow me.
Oh, okay, please. Yeah. Okay, Dr. Musa, please let me introduce regarding your background first, little bit to the audience. Okay, Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, good afternoon. Today is webinar or online seminar that the topics will present from Dr. Muazu. Dr. Muazu, he is a lecturer from the Faculty of Engineering, Electronic and Telecommunication Engineering Department. And his topics regarding the vehicle convoy control, artificial intelligence, IoT and Internet of Vehicle, and optimization and prediction. And his current university is Ahmadu Bello University. Ahmadu Bello University. And the latest publication that he have is such as scheme for extending the network lifetime of wireless rechargeable sensor network. It was submitted in Journal of Science and Technology. And the next one is beam divergence loss mitigation in free space optical communication channel using field of view technique, submitted in Journal of Science and Technology. And the next one is a preliminary study and implementing algorithm using finite state automaton for remote identification of drones. So this is very nice publication, and thank you so much, Dr. Mazu, for your time to prepare the everything. And I think me as moderator in this afternoon give you the best time for your presentation. So the floor is yours. I think you can start from now, and after your presentation, we will discuss regarding the topics. Okay, Dr. Mazu, please.
All right, thank you very much, Dr. Budi. Yeah, actually, you have already made the introduction, and I'm very glad to be here in your mix to share my knowledge. Though the slides was made in a rush, just in a day, but Alhamdulillah, we are going to try our best to discuss our findings and our results. Now, I would like to start. Bismillahirrahmanirrahim. The topic of this seminar presentation is information flow topology of vehicle control system. I am Dr. Muazu Musa Jibrin from the Department of Electronics and Telecommunication Engineering, Ahmadu Bello University, Zaria, Nigeria. Now, to start moving the ball, those are the things that we are going to discuss on this presentation. The first, I divided them into 4 parts. The first part will be an introduction on the vehicle convoy. Now we are going to look at the issues with regards to vehicle convoys. Now, what are the objectives that we try to achieve in this presentation? The scope, that is our limit. What are the contributions? Then we would like to look at the literature reviews, some of the literature reviews on that area. Then the second part, we are going to look at the effort made in addressing this problem of vehicle convoy. Then we'll look at our approach to solve that particular problem. In the approach, we are going to discuss the information flow topology, that is the IFT, of 2 ahead and 1 rear model. Then we would like to also explain the information flow topology of 2 ahead and 1 rear with model predictive control. And then the third part, we are going to discuss our findings. The findings are divided into 3 because the results are divided into 3 as well. Then the last part, we are going to look at the conclusion on the paper, and now the areas of this particular research, if any of the students or a staff is willing to venture into it. Now let's start from the first part, which is the introduction. Now we have to know that vehicle convoy is a string of interconnected vehicles traveling together for mutual support and protection. That is a vehicle convoy. Now the terms vehicle jack is very important for us to know from the beginning of this seminar. Vehicle jack is that which determines the passenger's comfort in a vehicle. When a passenger is inside a vehicle, now the comfortability of that particular vehicle, it depends on what is called the jack of that particular vehicle. That jack is nothing but the second differentiation of acceleration. When you differentiate acceleration, you are going to have what is called a jack. So that jack determines the level of the comfort of the passenger in that particular vehicle. Now, we will also like to look at the string stability of that particular vehicle. When a convoy is moving, or a vehicle is moving, that particular string of the vehicles should be in a stable form. So now that stability is the ability of a vehicle to move within a convoy without amplifying the oscillation of the lead vehicle upstream. I mean here is that when a vehicle is moving within a convoy, that particular vehicle must be stable. It's not going to be oscillating. Now, to achieve a stability within a vehicle, we have to look at two things. That is the information flow topology of that vehicle. That is the configuration of that arrangement of the vehicle, that is IFT. And then we will look at the control policy. The control policies are two. The first control policy is called variable inter-vehicle distance, while the second control policy is called constant inter-vehicular distance. Now let's look at one at a time. First, information flow topology of a vehicle, they have a lot of types. The first type that we can see here is called unidirectional communication. That is in this particular picture. We are going to realize that one arrow is looking at the lead vehicle. The first vehicle is called the lead vehicle, while the second vehicle is the following vehicle, if there are only two. So here we have only one arrow looking at it, meaning that here we have a unidirection, that is one directional communication. There is a case where we will have a bidirectional. A bidirectional in the sense that the two vehicles has an arrow that is bidirectional, that is two directional. The two vehicles can communicate. The leader can communicate to the follower, and the follower can also communicate to the lead vehicle. Then we have another type of topology, which is two vehicle look ahead communication. This particular communication, we have three vehicles. The first vehicle is the lead vehicle. The second vehicle is the predecessor vehicle, and the last vehicle is the follower vehicle. Now, in this type of convoy, the follower vehicle will be communicating, will be taking information from the lead vehicle and the predecessor vehicle. Another name of this vehicle is two look ahead. The two look ahead means the vehicle that you are controlling will be taking the information of the one close to it and the lead vehicle. That is two ahead. The vehicle will be looking at the first one immediately and the one above it. That is one of the driving habits of a driver. The driver will be looking at the one immediately in front of it and the one ahead of it, so that he is going to take a control on his own vehicle. If there is any brake matching by the predecessor or the lead vehicle, now the follower vehicle will have a time to adjust its control strategy so that he's not going to hit any of the vehicles. Now we have a lot of topology, information flow topology that come into existence. As you can see them down, we have the predecessor following leader, which is this type of topology. We have the bidirectional leader follower, which is this type of topology. And we have the two predecessor leader follower, which is this type of topology. And we have another one called two predecessor following leader, which is this type of topology. We have a lot in literature, but the most common topology is this, which is two vehicle look ahead communication topology. Now, the policy, if we are going to look at the control policy, I say there are two. The first one is the features for the first one is that of the variable inter-vehicular distance. In the variable inter-vehicular distance, you are going to realize that, as you can see in this diagram, the vehicle, they have a very wide space apart. The first vehicle is the leader, the second one is the predecessor, the third one is the follower, and now the back one is called the rear vehicle. If you are going to take full vehicle into consideration. Now, in this case, you are going to realize that the distance are proportional to velocity in constant time headway, which is CTH. And since they are very far apart, you are going to realize that they are going to produce very low traffic density. Only few vehicles will pass in a given time. Now, They are going to be stable, even with minimal communication. Even their communication between them is very minimal. You are going to realize that they are stable. The vehicle can move autonomous. This particular configuration, policy, the vehicle can move autonomous, and they are going to have very minimal risk of collision since they are very wide apart. Collision is going to be very minimal. Now let's look at the second feature. The next one is the constant intervehicular distance, which you see here in the next picture. We are going to realize that the difference between the first one and the second one, their spacing in between is very minimal, is very small. So here, you are going to have very high traffic density. A lot of vehicles will pass within given short period of time. While the communication between the vehicle is mandatory, you must have a communication protocol between the vehicles. And now here you are going to have very high risk of collision. Why? Because the vehicles are very close together. Collision between the vehicle is going to be very high. Now, we also know that in a big city, demand for high travel keep on growing as the population of the urban area grows. Now here, you're going to realize that in the city, it's very important to deploy the vehicle convoy on our highway because we want them to minimize traffic congestion, and they are going to facilitate people safety. They will cut down road production, as we know that the land is fixed. And now if we are going to continue producing roads, we are going to realize that a time will reach where we are not going to have even a place where to build our houses because our population keep on growing. Now we are going to continue.
Kalau situ kan bisa dibantu semua orang tuh.
We are going to continue producing roads. And now these autonomous vehicles, they will curtail fuel consumption, and they are going to decrease the driver stress. Now, the issues that we are going to that we are facing in this kind of vehicle system are vehicle convoy system suffer from unwanted string instability, discomfort with intervehicular spacing difficulties as a result of, first, adopting poor information flow topology. First, poor information flow topology is like that adoption of the one look ahead, two look ahead, maybe bidirectional, and the other information flow topology that we discussed earlier. Now we are going to realize that they have high acceleration and jerk, because in literature, the acceptable high acceleration in jerk, the acceleration should be 5 and the jerk should be 2. Okay, and now we are going to realize that the issues that are faced with vehicle convoy are poor in intervehicular spacing. We are going to realize that the intervehicular spacing is not enough. And now you are going to also have a problem of external disturbances, such as aerodynamic air drags. Now, the effort that we made to solve these particular problems are by trying to bring this information flow topology, which is a new information flow topology. This information flow topology is an information flow topology whereby we are going to have the lead vehicle, the predecessor vehicle, the following vehicle, and now the real vehicle. Now, what we introduce here new is the real vehicle. The real vehicle is going to be at the back of the vehicle that you are going to be controlling. This red particular vehicle is the vehicle that you are going to be controlling. The first vehicle, lead vehicle, the predecessor vehicle, and the rear vehicle, they are going to be moving autonomous. You don't have control over them. All your control will be only on your red vehicle, the vehicle that you are controlling. So that in the convoy, this particular vehicle that you are controlling will not collide with the lead vehicle or predecessor vehicle or the real vehicle. so that this particular vehicle is going to be stable, and the passengers that are inside that particular vehicle, they are going to have maximum comfort of traveling. Okay, now the excess why we add the rear vehicle in this particular control strategy is for this particular is for the control vehicle, because when you are driving with your car, you are going to realize that the mirrors of your vehicle will be helping you to be looking at the vehicle that is at your back. So that shows that there is important for you to be monitoring the vehicle that is in your back. That is why we added the rear vehicle, because now if they allowed you to travel without a mirror on your vehicle, you are not going to feel comfortable to move with your own vehicle in the convoy. So now that is why we introduced the rear vehicle, so that our vehicle will be taking control from the rear vehicle as well. Okay, now, within the effort that we made here, also is to develop a novel information flow topology of two vehicle look ahead and the rear vehicle, which I showed earlier. That is going to help us to give us a wider operational range, a realistic information flow topology, and the effective convoy communication. Then the next one, we are going to design and implement a control strategy for the vehicle control in A, and to investigate its performance, that is the string stability, ride comfort, against the conventional ones. The conventional ones are the 1 and the 2 vehicle control system via simulation. Now the third one, we are going to design and implement a model predictive controller, which is the MPC, for the information flow topology of A, for efficient, effective and robust, performance. And still we are going to investigate its stability and the ride comfort against via simulation. Now, the novel information flow topology that we are going to bring of the 2 vehicle look ahead and the rear vehicle system will be implemented. And this will provide a result and knowledge, new result and knowledge in the area of vehicle convoy. And still, the second thing that we say we are going to do is we are going to look at the overall new convoy control strategy, which will be designed and implemented. It will provide us with the high performance, string stability, ride comfort in the operation. And then we are going to implement the model predictive control based for the new topology. And this is going to provide us with a robust MPC based control, okay, for the new topology. And is going to give us an topology to efficiently predict and implement the positioning, tracking, jack, and it's going to ensure string stability with a post-pull minimum jack. And is going to handle constraints and is going to minimize the operation range, maximize the operation range for the convoy system. Now, if we look at the literature review, we are going to, for the literature review between the information flow topology and the vehicle convoy dynamics. In the information flow topology, you are going to realize that there are a lot of literatures that discourse on the homogeneous and the heterogeneous vehicle convoy dynamics. Now, here I give you a bunch of literatures that you can check that discuss on vehicle convoy dynamic homogeneous. And I give you some literatures that discuss on vehicle convoy dynamic heterogeneous. And here I provide you with some literatures that discuss on vehicle convoy dynamic hybrid. Hybrid in the sense that their vehicles are homogeneous and heterogeneous vehicles. When you have a homogeneous vehicle, the information flow topology is going to be give you a different result than when you have a heterogeneous vehicle, because the size of the vehicles are different. And as we know that due to loading and uploading, when you are traveling with your vehicle, let's assume now you are traveling with your vehicle, you have a full tank of fuel, and when you are moving, the fuel is going to be reducing, and now the mass of that particular vehicle is going to be reducing. So the result of that different vehicles, different masses, is going to give you, you are going to have different results due to air drag. You are going to be meeting air drag on the road that are going to be pressing that your vehicle not to move using the speed that you give it. Now here, I also give you information flow topology versus formation geometry. Here we have control policies. I discuss the control policies of the vehicle variable intervehicular distance and the constant intervehicular distance. So here are some literatures that publish on control policies using only vehicle variable intervehicular distance. And here using only constant intervehicular distance. And here I provide you some literatures whereby both are mixed. Then here I provide you also with some literatures for the performance matrices. The performance matrices that you can test your vehicle with. The first one is DC, driver's comfort. Then we have SS, which is string stability, and we have CS, which is cognitive behavior of the driver. So here I provide you with some literatures that discuss on the driver's comfort and string stability. And here I also provide you with some literatures that only discuss on the string stability of the vehicle as the performance matrix. And here I gave you a literature that discuss on the string stability and cognitive behavior of the driver. And here I give you a literature that discuss both. Now, here I also provide you with some controllers where you have the information flow topology versus the controllers. The first controller here is a linear controller. And here we have some literatures that discuss on vehicle convoy for using the linear controllers. And here we have literatures that discuss a vehicle convoy using the linear controller and the sliding mode control. Here we also have some literatures that discuss on the linear controller and model predictive controllers. And here we have a literature that discuss on the H infinities. Now, let's discuss on the topologies. Unidirectional vehicle convoy topology. We have a lot of authors that discuss on these unidirectional vehicle convoy topologies and their prompts. They provide means of driving information from predecessing SESO vehicle only. But their cons, this particular unidirectional, it lacks information from the lead vehicle and the rear vehicle to the control vehicle. This leads to a problem of chattering, overlap, discomfort, and it also minimizes the control range, which decreases safety. Now, if you look at the bidirectional vehicle convoy, we are going to realize that this bidirectional vehicle convoy, there are a lot of authors that discuss on it, and their pros is the ability to handle multiple input and multiple output systems, constraints, and they can predict future performance. But the cons that they experience during their implementation, the controlling system has no information of the speed, and also it has no information of the position of the lead vehicle. This leads to chattering, discomfort, and it also minimizes the control range, which decreases the safety of the vehicle. And we have two vehicle look ahead, and these two vehicle look ahead, we have autos that work on that, and their prawns, they provide means of communication with the predecessor and the lead vehicle. Here, their cons is that no information of the rear vehicle is available for the following vehicle. This leads to minimal oscillation and discomfort. It also minimizes the control range and decrease safety of the vehicle. Now, let's look at the controllers. Now, in the controllers, here we have the linear controllers, the PID, and the MPC. And we realize that there are a lot of autos that work on the PID, and their pros are the ability to give acceptable performance. And their cons, it is easy to implement it, as we know, PID, and is straightforward controller. While the MPC, we have one auto here that work on it, and the pros is the ability to handle MIMO and the constraints, and it can predict the future performance of the convoy. And also the cons here, it has very high computational cost and require high fidelity models. Then we have the non-linear models. The non-linear models are the SMS, sliding mode control, and the H infinity. Now, the pros are low sensitivity to parameters, and their cons, they cause chattering phenomenon, which can have a harmful effect to the model. While the H infinity, it has a problem of, it can be stable with, it can guarantee stability performance, but it needs high computational techniques and a reasonable good model for that particular controller to work properly. Now, let's look at our approach. In our approach, we model the two vehicle look ahead and one rear model using the spring and damper. Then the second approach, we use the model predictive controller to model the system. Now, this is our approach using the spring and damper. First of all, we provide the new information flow topology by looking at the relevant literatures, as we did earlier, and on the convoy model, the topology, and the controllers. Then it helps us to model an individual vehicle. Then now we design the new two look ahead and one rear vehicle topology. We test the model by looking at the spacing of the model. We check and be sure that our new spacing in between the vehicle is greater or equals to that of the one look ahead and the two look ahead. That is the conventional models. Then we go ahead. If we are satisfied with the spacing, then now we are going to test the speed. Now the speed, we test them so that they are going to be equal to that of the one look ahead or two look ahead speed. If the speed is okay, then now we'll move ahead to test the acceleration of the vehicles. If the acceleration of the vehicle is less than or equal to that of the one or two look ahead, then we are satisfied. We'll go and test the last parameter, which is the jerk of the vehicle. As I said, the jack of the vehicle is that which shows the comfortability of the vehicle, of the passengers in the convoy. So if the jack of the vehicle is less than or equal to that of one look ahead and the two look ahead, then we are satisfied. Now, here is our approach. First of all, this is what we use to model the two look ahead and one rear vehicle. Is the spring and the damper by using the Newton's law. We start using the Newton's law, applying the spring and damper. So we have this equation, that is the model equation given to you. And now we realize that the acceleration that you give is directly proportional to the matching of the total, that is the power that you are giving to your vehicle to move. And that power is equal to the control signal that we are giving to the vehicles to move. So this is the arrangement configuration of the vehicle with the spring and the damper attached to them. Here is the lead vehicle, and the distance for the lead vehicle is x, the position is x subscript I minus 2. And the position of the predecessor vehicle is x subscript I minus 1. While the position for the main vehicle that we are controlling, which is the controlling vehicle, is xi. And the position for the rear vehicle is x subscript I minus 1. So now here we are introducing the... Hello? 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 Okay. Now here we are bringing the CHT, that is the control policy, into play. That is here, and here we just shows how we are positioning the INT vehicle with respect to independent vehicles. And here is to linearize the subject to constraints. And here is the model we provide you with by using the Simulink. Okay, so here are the constants used in the modeling. All the constants that you need are given here. Here are the equations that give the constants. So that is how we achieve the model using the damper and the string and the damper. Now here is the model of the MPC, model predictive control. First of all, here we design the MPC, model predictive control, for the vehicle convoy, for the vehicle here. And here we integrate the MPC into the control strategy of the vehicle. And here we provide the robustness test for the MPC on the novel convoy control against the previous one that we produce. We test the spacing, speed, riding comfort, and the string stability. Here we did the same thing by checking at the spacing, speed, acceleration, and the jack. Now here are the equations for the MPC. The first thing here is the vehicle convoy. And as we can see from the equation, what we start is giving the force to the vehicle so that the vehicle will move. And we realize that we are going to have an air drag that will prevent the vehicle from moving. Then we are going to also have the final moving of the vehicle. So this, we change it into state space equation. And now here we bring the equation for the model predictive control. And here we provide with the augmented model. And then we give the cost function and we give the constraints. The constraints are like three. The first constraint is the constraint that is going to be between the control vehicle and the lead vehicle. The second constraint will be a constraint between the control vehicle and the predecessor vehicle. And the third constraint is going to be a constraint between the control vehicle and the rear vehicle. Now, this is the implementation of the MPC controller using the Simulink. All the tuning parameters are here given. That is the control horizon, the prediction horizon, and the sampling time. Now, here I would like to discuss the findings, what we find after implementing the two controllers. Now, finding and discussion. First of all, I would like to discuss what we find after comparison the two vehicle look ahead and one rear, that is the one that we implemented using the spring and damper, with the conventional one look ahead and one rear. Here are the results we get from the two vehicle look ahead and the one rear vehicle convoy. The spacing are these. The speeds are here. You can see the speeds are following one another without collision. And we also have the acceleration. The acceleration are these, while the jerk are these. So now let me discuss the results by comparing it with one look ahead. Now here is the speed, the positioning that we achieve for our vehicle. The red vehicle here is the vehicle that we are controlling. And you are going to realize that the red vehicle is not colliding with the rear vehicle. This black is the rear vehicle from the legend, and the two are the lead vehicle and the predecessor vehicle. While this is the conventional, the one in existence, you are going to realize that the conventional, this is the control vehicle, which is the red, and the predecessing vehicle is the blue in color. And now this is the result that we have. Related to the position, we realize that we have a wider space apart of 35 meters maximum between each vehicle in the one that we implemented. While the conventional one, they have 29.3 maximum spacing. Now, this model that we implemented is visible throughout the simulation. You are going to realize that you are visualizing your simulation. While this one look ahead, when you implement it, you are going to realize that it will truncate, meaning you are not going to continue seeing your result after 115 seconds. Okay, it will truncate. Now we are going to realize that by looking at your result is smooth and is free running. While the one look ahead, you are going to realize that it has a lot of chattering from 0 to 64 seconds. From this position to around 64 seconds, they are chattering. There are a lot of chattering. Okay. Now here you are going to realize that we have an improvement in this result, in an improvement in an increase in intervehicular spacing of 19% against the one look ahead. And our result is visible throughout the journey and is free from chattering. Now, when we compare the speeds, we are going to realize that our speeds are smooth, while the speed of the one look ahead, they are overlapping. Look at them here, they are overlapping. So now our result is visible, but they are on truncated after 45 seconds. Now our on is free from free running. Now here, we are going to realize that we have very smooth and steady speed is visible and free running. Then now, when we compare with their own acceleration, we are going to realize that our acceleration is 0.9 meter per second square, while their own is 1.129 meter per second square. So now, the acceptable acceleration is 2. acceptable acceleration from literature is 2. Their own is acceptable, but actually that particular car is not going to be very, very comfort when you are moving with it as compared with the one that we implemented. And still the acceleration, it has a lot of chattering, which you can see here. So now in acceleration, there is an improvement of 20.29% acceleration as compared to that of the one look ahead. Now let's look at the jack, which is the comfortability of the vehicle in the car. The acceptable jack is 5. The acceptable acceleration is 5. The acceptable jack is 2. Sorry. So now when you look at the jack that we achieve here, the highest jack, the highest amplitude is 0 of the control vehicle, which is the red vehicle that we are controlling, is 0.43. Look at it here, 0.43. And their own highest jack is 0.574. So this simply shows that we have an improvement of 25.9% and is free from chattering. Now let's look at our second finding. That is when you compare the two vehicle look ahead and the one rear and that of the conventional two vehicle look ahead. Now you are going to realize that in the positioning, we have 35 meters apart. Their own is 29.6 meters, and we have an improvement of 18.2%. Now, when we look at for the speeding, you are going to realize our own is smoked and their own is smoked too. And also our own is visible throughout the journey and their own is also visible throughout the journey. But our own other behaviors, controlling vehicle, the perfect. Actually, in the speeding, there is no significant improvement between the two. Now, when we look at the jack, our acceleration is 0.9 meter per second square, where their acceleration is 1.06 meter per second square. Here we have an improvement ahead of their own, which is 15.17% improvement. And their own, they have a minimum oscillation of, when you look at from 10 seconds to 35 seconds, there is a kind of small oscillation they have, while our own is free from oscillation. Now, when we compare the jack, we are going to realize that we achieve a jack of 0.43 meter per second square cube, while their jack is 0.46 meter per second cube. And they are still having some chattering from 10 to 35 seconds. Their vehicles have a chattering. Now in improvement, we are having an improvement of 6.25% improvement ahead of their own model. Okay, now let's look at the next finding. In the next finding, we are going to compare our own two vehicle look ahead and one rear model with MPC. That is the last model that we designed, with that one with string and damper without MPC. So that we are going to challenge our previous model with the model of MPC that we designed. This is the result that we achieve using the model predictive control in the vehicle convoy. Now, this is the comparison between the one with the model predictive control and the one without the model predictive control. Now here, the one with the model predictive control, we realize that the positioning between the vehicles is very wide apart. That is 39.85 maximum, while our previous model that we designed is 35 meters wide. This simply shows that we have an additional improvement ahead of our previous model of 13.89%. And this shows that we are going to have a very control of our vehicle without colliding each other. We'll have a wider space apart, so that we are going to take decision whenever we see any of the lead vehicle or predecessor vehicle match their brake. And when we look at the speed, we are going to realize that still we have a control over. If this is the position A in the speed of that with MPC, and this is the position B, now we are going to realize that the controlling vehicle, the red vehicle, is not at the center of the real vehicle and the predecessor vehicle. Meaning the MPC is learning, is predicting when there is a curve. If there is deceleration, now the MPC will move very close to the predecessing vehicle, so that is going to give the rear vehicle a room to move, either to accelerate or to decelerate, or to increase the speed, whatsoever it wants to do, so that it's not going to collide. While when you look at the one without the prediction, you are going to realize that the red vehicle, that is the controlling vehicle, it maintains at the center. Whether the real vehicle match brake or accelerate, or the predecessor vehicle is accelerating, is going to maintain at the center. So now the one with the MPC, it has the knowledge of the real predecessing, and it can predict their own behavior if there is bend or there is acceleration or deceleration, so that it's going to give a room for them not to collide to it, while the one without that MPC is not providing that particular room, though all of them are smooth and their maneuvering speed is good. But that with the MPC, it predicts possibilities of collision, and it adjusts itself. Now, when we look at the acceleration, we are going to realize that with MPC acceleration is 0.611, while that without MPC is 0.9. So this simply shows that we have an additional improvement in that with MPC of about 32.11%. Now, when we compare the jack, that is the comfortability of the passengers, we are going to realize that with MPC will give us 0.163%, while the previous one without MPC is 0.43 meter per second square, per second cube. This shows that we achieve an improvement of into reduction in the jack by 55.12%, which is more than 50%. Now, here are the performance matrices that we discussed earlier. Those are the positioning, what we achieve with the one look ahead, two look ahead, and the one that we implement, and the MPC. So at a glance, you can see the results. Now for the acceleration, those are the acceleration that we achieve for the one ahead, two ahead with rear, two ahead, and MPC. And also for the jack, those are the results we achieved. Now, here, take us to the last part, where we are going to conclude and discuss on the area of research and the key references. Now, in conclusion, we are going to realize that the proposed Nobel information flow topology of two vehicle and one rear vehicle convoy has been implemented, which gave a wider operational range, as we see, over the two conventional for effective communication and a more realistic vehicle convoy. And we also see that a control strategy for the novel information flow topology has been implemented to provide the convoy performance. Better results has also been achieved against the conventional models under various parameters and simulation. And we also see that a combination of the novel information flow topology and that with MPC has been designed and implemented. The performance of the proposed robust combination has been compared with that one without MPC, and the following can be concluded. It is effective in prediction of changes in the independent vehicle speed, position, and hence that one with the MPC adjusts its position and speed for safety. It also proved that that one with MPC, it has the ability to be stable and maneuver. Hence, it avoids the possibilities of any collision. And we also see that it is visible and smooth in changes of the vehicle speed. Hence, it provides an acceptable acceleration and ride comfort. And we also see that it is robust in constrained handling, and it maximizes the control range. And also, the novel information flow topology with MPC against the 1 and the 2 and the 1 and rear with MPC achieved the following improvements. An increase in the intervehicular spacing was seen of 36%, 34.56%, and 13.83% respectively. We also realized that it is smooth and maneuvering speed. It has a maneuvering speed, it is visible, chattering free, and ride comfort. We also see that a reduction in acceleration by 47.88, 42.41, and 32.11% respectively was achieved. And also a reduction in jerk by 66.38%, 58.04%, and 54.12% respectively was also achieved. Hence, it is therefore important to give more emphasis not only on the vehicle control slinky effect, but also the choice of information flow topology, because we realize that the vehicle information flow topology of 2 look ahead and 1 rear is very important. Now, here are some areas for research if you want to go ahead of what we did earlier. You can make a research on the flow of information. That is, the task could be, this task could be fulfilled when an in-depth research is done, concentrating on the flow of information and communication delay between the vehicles. Because we realize there are some delays that may happen when a vehicle is communicating between one another. Also, vehicle dynamic model can also be looked at. This is likely to involve more detailed modeling of the vehicle traction control system, TCS. And also, vehicle join and leave can also be implemented, because when you look at this model that I discussed, it's only one directional of freedom. It's only move in a straight line. So you can consider to create a vehicle joining the convoy and leaving the convoy at will. Although the effect of joining the convoy and leaving the convoy has not been investigated for this novel topology, and this should be investigated in conjunction with a more robust controllers. And fourth, the practical implementation of this particular information flow topology, vehicle convoy, can also be created in such a way that a prototype of the novel topology could be implemented and test run. Therefore, the actual of the topology on the real vehicle system can be seen. Thank you very much for this, for listening. Thank you.
Yeah. Okay. Thank you so much for the nice talk, Dr. Muazu. This is very interesting for us that you present your research and the result from your research. Question from Mr. Rifki Swandi in the chat box. Maybe we can start from his question. His question is 4 vehicles the minimum number of vehicle for this method or to work properly? And what is the maximum or optimal convoy size for this method?
All right, thank you very much for this question. Actually, for a human vehicle driving habit, for you to drive your car and feel comfortable, you have to be viewing 2 vehicles ahead. When you are driving, your eyes must be seen at least 2 vehicles ahead and 1 vehicle rear using your own mirror. So the more you increase the number of the vehicle, the more realistic, the more safety your vehicle model and driving will be. If you can see 3 vehicles ahead, 4 vehicles ahead, if your eyes can see your sight eyes, that is the sight, your eyes can view more vehicles, the better. So if you can see from our earlier discussion, we are seeing only the vehicle that is into existence is only 1 look ahead. Then we see bidirectional, he can see front and back, only 1. Then now the current literature review created by Associate Prof. Shahadan from University Technology Malaysia is that of the seeing 2 look ahead vehicle convoy. And that 2 look ahead vehicle convoy is the one, is the state of the art before we create 2 look ahead and 1 rear. So the more you are viewing, your controller can view the number of the vehicle, the more safety you will be. So now the state of the art is to have 2 look ahead and 1 rear. But if you want to go a little bit higher to make your controller more realistic, to have better results, then you have to view at least more than that. But you have to get a literature to back that up. Thank you.
Okay, thank you, Dr. Muazu. Yeah, Mr. Rifki say something in the chat box that I see no wonder in Indonesia the number of vehicles in convoy which usually cause a lot of problem is 2 to 3 vehicles. Yeah, thanks, Prof. Yeah, consider with Mr. Rifki question. I also want give you a question regarding the for 2 vehicle ahead. I think in the convoy, it mean we also need consider regarding the range for the controller vehicle, radio range, something like that.
Sorry, I haven't get the question clear.
Yeah, regarding the, did you set the radio range for the controller to communicate
Actually,
with the vehicles?
The control range usually increase when you can view more vehicles. In your controller, you can have a sensor on board control. That is when the vehicles are very close together. They can only be controlling using sensors. So that one, each and every particular sensor that you use, it has its own range that you can use to control your vehicles. But here, you can make your vehicles to have a very wider range if you want. When you are incorporating Internet of Things, maybe you are using the Internet of Things. And now when you're using the Internet of Things, you can also be, your vehicle convoy can take a control of a vehicles that are very far away from it, not necessarily the one that are very close to it. So the more you are increasing, if you are not using a sensor on board, which is not what we are actually using in our own convoy, you are going to realize that the more you are seeing the vehicles that are in front of you and the rear vehicle, the more range of control that you are going to be having. Thank you.
Okay, I see, I understand. So the radio range increase when the neighbor vehicle increase also, I think.
Yes, exactly.
Yes. Yeah.
Because you are taking your information from the neighboring vehicles, their speed and their acceleration are coming to you so that you are going to adjust your own speed and acceleration not to collide.
Okay, interesting. Okay, thank you, Dr. Mazu, for the answer. Okay, any more question? Please raise hand, audience. Yeah. Yeah, we have a question first from Lukman and after that from Leonel. Mr. Lukman, please.
Yes, Mr. Budi, thank you for chance for me to ask Dr. Muazu. Dr. Muazu, introduce myself. My name is Lukman Muhakim. I'm the first. I'm too interested for your topic because this topic so is new topic for me, new knowledge. I'm not wonder to think about this convoy. This I wanna ask about something. That's right. For now, what the main focus in developing the MPC control model for the new era EFT and the vehicle convoy system? Maybe that's my question. Thank you, Dr. Muazu.
All right, thank you very much. If I get you clear, are you asking of the reason why we implement the MPC? Dr. Budi, is that
yes.
the question?
All right. Yes. Yeah.
All right. Yeah, actually, MPC, as the name it is a model predictive controller. And when you are driving in convoy, there are a lot of unforeseen circumstances that may arise. Maybe air drag, maybe you will just realize that one vehicle will just leave the convoy. Maybe the vehicle that is following you will increase the speed without you knowing. Maybe a lot of unforeseen circumstances may arise. Maybe you will have a gallop on the road or a sharp bend. So you have to train your model so that your model can predict. So that MPC, model predictive controller, is learning and is predicting what is going to happen in the future. So that is going to help your model to predict. Model predictive controller can be, though has a very high computational involvement in it, but model predictive controller can also be applicable to a lot of control design if you want to predict some unforeseen circumstances, some things that may arise. So you can use model predictive controller. We use model predictive controller because we know that in vehicle convoy, there are a lot of things that may arise, which we want that our model to adjust. You know, the first model that I presented using spring and damper, it has like 4 different constants. And those constants, we are tuning them manually. It's trying and error tuning. But when you are using that model predictive controller, it's going to learn and it's going to tune that particular parameters by itself. If there is reduction on speed, you don't need to go and tune the parameters. If there are, so model predictive controller is performing all those kind of things. That is why we implement it. And model predictive controller is MIMO, is allowed multiple inputs and multiple outputs. So there are a lot of input of the speed, acceleration, positioning that is it allowed in, and it give you out multiple inputs, the speed, positioning, a lot of things. So that is why we use model predictive controller. And also in addition to that, that is something that we call MRAC. That is model reference adaptive control. Model reference adaptive control can also be used to improve the previous model because it can tune the parameters automatic without you tuning them as well. Thank you.
Okay. Thank you, Dr. Mazu, for the answer. Okay, next question is from Leonel, I think.
All right.
Leonel, are you here? Can
Yes.
you hear me?
All right. Yeah.
Oh, okay.
Thank you, Professor. Professor Muazu, my name is Leonel. I would like to ask a question. So, if there is a new vehicle which is suddenly moved between the convoy, vehicle convoy, let's say the new vehicle is suddenly moved between the precedent and follower vehicle. So, is it affect or it makes any change from the speed or spacing or acceleration for the convoy vehicle? Is there any I mean, is the model predicting controller from the vehicle convoy will be destroyed, or it's still working if there is a new vehicle that is not automatically following the line of the vehicle convoy? Maybe that is my question. Yeah.
All right, if I understand the question, you say if there is a vehicle between the lead vehicle and the predecessing vehicle, does that affect the MPC? Is that the question, please?
Yeah, yes, yeah.
All right. Now, for you to use an MPC, you must have a model. And that model is the model of your vehicle. Now, you must also have what we call a control strategy, the topology of your vehicle, I mean. The MPC can also be used, always be used when you have a model and your strategy. Now, the model is the model of the vehicle, and the information flow topology is the arrangement of that your vehicles. Now, you mean you have 3 vehicles ahead, and you have 1 rear vehicle in this case. You added 1. So meaning your topology is a topology of 3 vehicles ahead and 1 rear. So if you have 1 vehicle ahead and 1 rear, that particular model is what you are going to use and form your model predictive controller. If you have 2 vehicles ahead and 1 rear, that strategy are what you are going to use to form your model predictive controller. So now you have 3 ahead and 1 rear. So those combination of a new model that you have are what you are going to use to form your model predictive controller. Whatsoever addition that you make is going to affect your model predictive controller. Your model predictive controller for 1 vehicle look ahead is not going to be the same model predictive controller for 2 vehicles move ahead, and it's not going to be the same for model predictive controller for 3 vehicle move ahead. Each adjustment that you make on your information flow topology, you have to make that particular adjustment in your model predictive controller. So it's going to affect the model predictive controller, whatsoever adjustment that you make in your information flow topology. Thank you.
Okay,
Thank you
thank
so
you,
much,
Dr.
Professor.
Mazu. Yeah. Leonel, any more question? Okay, we have another question from Ikrar. Okay, Ikrar, please.
Thank you, Mr. Budi. Okay, I want to say thank you, Dr. Muazu, for giving this very good seminar. First, introduce myself. My name is Internasional, and from the material in this seminar, I take a question. Can this method also be used on the motorcycle? Because in the material, I only saw example of cars, and in Indonesia there are motorcycle user than cars.
All right. Thank you, Ikra. This is a nice question, because what differentiates a motorcycle and a vehicle is that in this particular presentation, I use a motorcycle. Motorcycle are moving, and I use a vehicle. Motorcycles also are moving. So I have a model that I did. Still, I use the MPC, but this time around I use them on a drums, and I make a convoy on drums. During the COVID, we simulate the drums in such a way that the drums can take COVID samples from where they are taken to the hospital directly, and then landed the samples without the patient taking himself to where he's going to be taken. Doctors will take the samples and they move. No, the doctors will come to your house, take your sample, put in the drum will fly to a designated place where it will land for the lab people to take the sample and make the test. So all that can be applied. You can apply the model predictive controller on them, so that they can predict. But that one, you have to apply something called SLAM, simulation, localization, and mapping. If you are going to use maybe drums, because they are on the sky, there is no road, you have to know your terrain, you have to do simulation, you have to know your locality, and you have to map for them to work properly. But here we are talking about a motorcycle. Motorcycle are the same with vehicle in this case. It's only that how your motorcycle is going to be stable, because it has only 2 tires. So a vehicle is stable already. It has 4 tires. Yours is just to use your controller and allow the motorcycle, the vehicles to move and do whatsoever you want them to do without colliding. But motorcycles, you have to balance them so that they are going to be stable before you can use your controller, MPC, whatsoever, and have the model of the motorcycle before you can apply your MPC. Yes, you can apply MPC on any model that is applicable to it. Thank you.
Thank you, Doctor.
Yeah, thank you, Ikrar. Okay. Yeah, Dr. Muazu, I'm interesting based on your slide number 41, yeah, that you discuss about the improvement achieved in speed. Yeah. How about the delay in this case?
Okay, sorry, please. Slide number 41.
Yes, 41.
Yes. All right. Please, sorry, what is the question?
Yeah. You was introduced regarding the improvement achieved in speed, right? So it means the delay time is reduced also, or maybe 0 something?
All right. Here in the speed, there are a lot of improvements because the MPC predicts. So, but actually, you are right. If you are going to improve one thing, then you are going to realize that you are going to have some shortcomings. You are going to trade up. But in this case, because the MPC is predicting and move the control vehicle either front or back, as compared to the previous one that remained at the center, whether the collision will happen or not. Here, because of that movement, it will take time to move it front. It will take time to move it back. Then still we are trading off speed here. Here we are going to have some delay for the controller to effect the efficient safety position for the vehicle either to move front or rear. Yes, here there is trade-off in the trade-off. Here we are going to encounter some delays as compared to the one with the spring and damper, but we are going to have a very high safety here. Okay. Yes, thank you.
Yeah. Oh, that's very interesting. Yeah, thank you, Dr. Muazu, for the explanation. Yeah, we have a question from Mr. Rian Ferdian in the chat box. Dear Dr. Musa, one question regarding your presentation is jerk has a correlation with acceleration and speed. With acceleration and speed, with the passenger conform, determined by jerk, not speed or acceleration.
All right, thank you very much. Jerk, from the beginning of the seminar, I defined what jerk is. Jerk is the comfortability of the passengers in the vehicle, because I know jerk is very important. Jerk is the comfortability of the passengers that are there inside the vehicle. So jerk is the third differentiation of displacement. When we have displacement, we differentiate it. We have speed, velocity. When we differentiate the velocity, we have acceleration. When we differentiate the acceleration, we have what is called jerk. That is, we are having the unit of meter per second cube. So that jerk determines the amount of the comfort of your car. If you know the speed of your car, you can easily differentiate your speed to know the jerk. If you know the jerk, you can know whether that particular your car is comfort or not. This model vehicle, they have a very low jerk. You are going to realize that when you fill a cup of water and put it on top of the engine of a model vehicle and you start the engine, the water will not even split because of the comfortability of that particular engine of that car. So jerk determines the comfort of the passengers that are inside the car. It's not the speed and it's not the acceleration. It's the third differentiation of the displacement. Thank you.
Okay, thank you, Dr. Muazu. Yeah, I think I skipped one question from Mr. Rifki in the chat box. That his question is, what is the impact of sharp turn on the road if we use this method? Considering that the road is in Indonesia have a lot of sharp turn. Yeah.
All right, thank you. Unforeseen circumstances like the sharp road, air drag, and so on, they are what make us to start thinking of MPC. Because that one with the string and damper is not taking unforeseen circumstances into consideration. So that is the importance of coming with model predictive controller. That is the MPC. So the MPC is the one that is helping the model when there is a sharp bend, as I showed in my previous slide, the slide that I just closed, when there is a sharp bend or there is air drag, all those unforeseen circumstances actually are taken care by the model predictive controller. Thank you.
Okay. Okay, thank you, Dr. Muazu. Yeah, we have one question more in the chat box from Aulia. Assalamualaikum, Prof. Allow me to introduce myself, Aulia Rahmadani from Computer Engineering Department. I have one question. Is there a possibility of a failure in data processing, such as a convoy of vehicle out of range that cause a fatal accident? Thank you.
Sorry, I haven't get the question very clear.
Yeah, Aulia Ramadhani, are you there? Rama? Okay, maybe we can go to the next. Yeah. Can you repeat your question?
I have a question, Prof. Is there a possibility of a failure in data processing, such like a convoy of physical of range that cause a fatal accident?
I'm afraid up to now I haven't understand the question.
Hello, Rama.
Dr. Budi, if you understand the question, please explain it for me.
Yeah, halo Rama.
Ya, Pak.
Ya, mau nanya
Boleh
apa?
Pak pakai bahasa Indonesia, Pak?
Ya, silakan.
Jadi ini Pak, jadi misalkan si processing data, pengolahan data ini nggak berjalan dengan baik, apakah ada kendala gitu Pak yang mengakibatkan kecelakaan yang cukup fatal Pak? Mungkin itu Pak.
Okay, yeah, Dr. Muazu, his question is regarding the data processing. If the process is not a success, it can be impact for the accident in the road, something like that.
I understand. Yeah, actually, any design that is not robust may encounter some problems related to the computational things that may happen in it, and that may lead to very high fatal accidents. But when you are going to allow autonomous vehicles on our roads, you have to put a lot of things into place so that you are not going to have such kind of things. Here is not very robust because here is only a simulation we made. We haven't made them physical to see the effects, but provided the mathematical expressions that you make in your model and your prediction are correct, then it's going to be obeyed. Otherwise, it may lead to a very high fatal accident on our road. Yes.
Okay. Thank you for the explanation and answer, Dr. Muazu. Yeah, I think Rama need test by experiment regarding his question, I think, right? So yeah, simulation give maybe a better result compared than experiment, but we will get interesting result also by experiment, I think. Yeah, that is maybe future research topic maybe. Okay, Dr. Muazu, I think we still have one question from Leonel. Yeah, by the way, Leonel is our international student. He came from Madagascar, Dr. Muazu, and he is the last year for bachelor degree in our faculty this year. So he is very interesting with your topic, I think. Leonel, please.
All right. Thank you, Prof. Maybe this is my last question. I would like to ask the difference between novel topology convoy control and the conventional to look ahead convoy topology control, because I see in here the things that I would like to ask in that is how if the vehicle convoy will not respect the equal spacing, because in here it is 35 meter for maximum between the vehicles. So what is the difference between novel and the conventional one? Even if from both of these convoy control will not respect the equal spacing if the vehicle will not respect the spacing. Maybe is it clear? My question, maybe I just want to ask the difference between novel topology convoy control and the conventional one. Maybe that's all, Professor. Thank you.
Yeah, Lionel, I understand. Yeah, actually, the difference between the novel topology and the conventional are, from the beginning, we realized that the conventional, from history, we have only one look ahead, the one that can only look at the leader. Then now we have another one, which is bidirectional, the one that can look at the leader and look at the leader can look at the one following up by itself. Then we have two look ahead. The two look ahead are the ones that are looking at the follower is looking at the predecessor and is looking at the leader as well. Then we implement two look ahead and one rear, so that the two look ahead and the one rear can provide us with a lot of things like the spacing. Yes, the spacing cannot be the same thing, because the spacing between that with one look ahead is different. The spacing with two look ahead is different. And the spacing with the one that we created, two look ahead and one rear, is different, which is about 35 meters, if I can remember. Then now we realize that that 35 meters is not even enough. We want to have more realistic, more robust. Then we bring into existence the one with MPC. So the one with MPC, if I can remember, it gives us like 39 point something meters. So the higher the spacing in between, the higher the safety of that particular convoy not to collide with any one another. The spacing may not necessarily be the same, but we want to achieve higher spacing. Then we want to achieve lower jerk. We want to achieve lower acceleration. I hope you understand. The one that is conventional, that is one look ahead and two look ahead, they have smaller spacing, maybe 33 or 32 meters. I can't recall. But the one that we make using the spring and damper, it increases in the spacing in between the vehicle. You realize that when you are following your friend, you are driving, if your distance in between is wider, is very safer for you than when your spacing is very smaller. If the spacing is very smaller, the risk for you to collide with him or he to collide with anyone that is close to him is very smaller, because provided he match a brake, before you adjust and match your own brake, is late. You realize that you have already hit him. Then you realize that, hey, this person match a brake. So the wider the spacing that you achieve, the more safer your convoy will be. I hope you understand.
I got it. Thank you so much, Professor.
Okay. Okay, thank you so much for the explanation, Dr. Muazu and Lionel. Thank you so much for the question. Okay, Dr. Muazu and audience, I think that's all our agenda in this afternoon. And we are very appreciate with your time and nice talk, Dr. Muazu. We also understand that you are just arrived in your country from Mecca and maybe tired. So we appreciate your time and nice talk. Mr. Ahmad, hello. Pak Ahmad. Halo Pak Ahmad Padekan. Okay, maybe yeah. Okay, everyone. In the chat box, you can check the link for the absent. Please fill the links. And next, I think we will take a photo together. So please turn on the camera Mr. Rifki, can you help us to take the photo? Or Ibu Mita?
Of course, sir. I would like to head all of you to take the picture together, and I'll count 1, 2, 3, and give your best smile.
Okay.
Okay. So for the first slide, please open your camera for our special audience and special guest. So I'll count 1, 2, 3. Wait a minute. For the second slide, 1, 2, 3. Wait a minute. Then for the next slide, please open your camera. I'll count 1, 2, 3. And then for the last 1, 2, 3. Okay, thank you very much.
Okay, thank you so much for your nice help, Ibu Mita. Dr. Yan, you want to say something? Yeah, Dr. Yan Ferdian is our head of department, Dr. Muazu. Maybe you want to say something, please?
Yeah. Thank you, Dr. Musa or Muazu. How should I call you?
Muazu, sir. Yes.
So you can speak Malay? Dapat cakap Malay sikit-sikit? Cik Muaz. So thank you very much, Dr. Musa, for the presentation. It's a very interesting topic. It's very rare for us to have a chance like this. And also thank you for the how to say it, PCU, the WCU. It's English, right? World Class University Department of Universitas Andalas. Thank you very much that this webinar can happen. Mr. Maki and Bu Mita, thank you very much. And also Pak Dekan tadi yang Pak Dekan already as an opening speech at the beginning of the webinar. And Mr. Budi, the moderator for this webinar. And Dr. Musa,
yes, sir.
From Nigeria, right? It's
yeah, from Nigeria.
Nigeria, yeah. And how long have you been in Malaysia? 10 years? 5 years?
4 years in Malaysia. Then I came back and lectured for 2 years in University Technology Malaysia. And then I returned back.
Okay.
Okay.
So you got
We hope we can.
position, eh?
We hope we can also visit your country someday.
Yeah, you are welcome.
Yeah, Mr. Budi already have a plan for Africa tour, right, Mr. Budi? You want to see Leonel country also, Madagascar, and also go to Mecca, Saudi Arabia. Inshallah. Maybe that's all, Mr. Budi.
Okay,
Yeah.
Thank you so much, Mr. Rian, for the closing statement. Okay, Dr. Muazu, we hope you have a nice day, and we hope you can visit Andalas Universitas Andalas in the future. Yeah, you should join here offline, but we understand that you just arrived from Mecca. So this is very interesting, and we are very appreciate. And thank you so much, Dr. Muazu. Thank you so much, student audience. And I think that's all. And maybe we can close this Zoom meeting. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih.
Dr. Muazu, thank you.
Thank you very much,
Terima
Dr.
kasih.
Muazu.
Bye. See you next time.
Bye.
Yeah.
Thank you, Bu Mita. Thank you all.
Thank you, Pak.
Ya,